Hi, I'm Matt, and in this video we are going to go over calorimetry. So before we get into the math of calorimetry, what exactly is calorimetry? So calorimetry is the laboratory technique used to determine how much heat or energy is absorbed or released in a reaction. To do this, we cause a chemical reaction in water, or we burn something underwater and measure the change in that water temperature. And then using that change in temperature, we could figure out how much heat was released using an equation I'll introduce shortly. That equation is Q equals mc delta T, where Q is the amount of heat that was absorbed or released. If heat was absorbed, Q is going to be positive, and if heat was released, Q is going to be negative. M will be the mass of the substance. C is the specific heat of the substance. This is the amount of energy required to increase the temperature of 1 gram of substance by 1 degree Celsius or 1 degree Kelvin. Each substance has its own specific heat. And finally, delta T is the change in temperature and is equal to the final temperature minus the initial temperature. Sometimes in a question, it's more convenient to write T final minus T initial instead of delta T. Let's try some practice with this equation. For our first example, we are asked how much heat is absorbed when 50 grams of water is heated from 30 degrees Celsius to 40 degrees Celsius, and we're also told that the specific heat of water is 4.18 joules per gram degree Celsius. So, we're going to start by writing our formula, Q equals mc delta T, and writing our givens. We're told that our mass is 50 grams, and that our specific heat is 4.18 joules per gram degree Celsius. Now, we're not explicitly given delta T, but we're told our initial temperature and our final temperature. Since we're heating 30 degrees Celsius to 40 degrees Celsius, Ti, or our initial temperature, is 30 degrees Celsius, and our final temperature is 40 degrees Celsius. Next up, we're going to go to our equation. We're going to get rid of delta T and replace it with T final minus T initial in parentheses. And then after that, we just have to plug in. So we get Q equals 50 times 4.18 times 40 minus 30. Then to do the math, we're going to simplify the 40 minus 30 and get 10. So we get Q equals 50 times 4.18 times 10. And multiplying through gives us that Q equals 2090 joules. Joules is our unit for heat. And that is our final answer. For our second example, we are told that 30.2 grams of a metal releases 195 joules of heat to its surroundings. If the temperature decreases by 50 Kelvin, what is the specific heat of the metal? So we're going to start off by writing our equation, Q equals mc delta T. Since we're looking for our specific heat, we're going to be solving for C in the equation. Now, let's go to the side and write our givens. We're told that Q is 195 joules, but we're releasing 195 joules of heat, so we're going to write it as negative 195. We're told that our mass, or M, is 30.2 grams, and then we're told that the temperature decreases by 50 Kelvin, so we're going to write delta T, or our change in temperature, as negative 50 Kelvin. And now we could plug into our equation. So we get negative 195 equals 30.2 multiplied by C multiplied by negative 50. Multiplying the numbers on the right side, we get that negative 195 equals negative 1,510 times C. To get C, or the specific heat, by itself, we're going to divide both sides by negative 1,510, and that gives us that C, or our specific heat, is equal to 0.129 joules per gram Kelvin, and that is our final answer. For our last example, we are told that an 160 gram sample of water initially at 300 Kelvin absorbs 3,360 joules of energy. If the specific heat of water is 4.18 joules per gram Kelvin, what is the final temperature? So just like the last two examples, we're going to write our equation Q equals mc delta T, and then go to our right and write our given. So we're told that we're absorbing 3,360 joules, so that's the value of Q, and it will be positive since we're absorbing the energy. They tell us that the mass is 160 grams, and then they tell us that the specific heat is 4.18 joules per gram Kelvin. Now they don't give us delta T, but they give us our initial temperature, which is 300 Kelvin. So, being we only have the initial temperature and not the final temperature, we're going to go back to our equation and rewrite it as Q equals mc times T final minus T initial. And then we could plug in what we have. So we get 3,360 joules equals 160 grams times 4.18 joules per gram Kelvin multiplied by T final minus 300 Kelvin in parentheses. And then we're going to multiply 160 times 4.18 to clean it up a little. That gives us 3,360 joules equals 668.8 multiplied by T final minus 300. We want to get that parentheses with the T final minus 300 by itself. So we're going to divide both sides by 668.8, and that gives us that 5.02 equals T final minus 300. The last thing to do to get T final by itself is to add 300 to both sides. This gives us that the final temperature was 305 Kelvin, and that is our final answer to the correct amount of significant figures. Now that we've gone through 3 examples together, here are 3 practice questions for you to try on your own. The first one asked you to solve for mass, the second one asked you to solve for heat, and the third one asked you to solve for the final temperature after heat was added. So, at this time, I encourage you to pause the video and try them on your own, and the answers to these questions will be provided for you on the next slide. The solutions are as follows. In question 1, the mass was 6.00 grams. In question 2, 418 joules have to be absorbed. And in question 3, the final temperature was 38 degrees Celsius. Hopefully you got these. If not, feel free to leave any questions you have in the comments below, and I will get back to you as quickly as possible. Thank you so much for watching. Have a great day.